Everybody, and welcome back to another math video. This one is going to be covering solving quadratic functions, and we've actually done a lot with graphing quadratic functions. Many of you did that back in section G3. So if you have not seen graphing quadratic functions or shapes that look like this, make sure you check for old videos before you get to this one. So a quick review on graphing quadratics. When we're working with quadratic functions, they are always written in the form ax squared plus bx plus c, and that equals y. So for our problem down here, the number in front of x squared is 1. There is no b value, so that is 0. And our c value would be -4. And the reason why we find these is to help us figure out the vertex of our quadratic function. And the vertex is always going to be either the minimum or the maximum value. For the problem on the left, our vertex is our minimum value. The formula for the vertex is opposite b over 2a. For our problem, it's about as easy as it gets because it's 0 divided by 2. So our vertex is the point 0, comma something. Now, for the sake of time saving, I filled out the rest of our table for this. With our vertex being 0, we then need to pick points that are equidistant away from the vertex. So for this one, I did 1 and -1, 2 and -2. Now, I actually have a typo here. This should be 0. Sorry about that. So for the table on the right and the graph on the left, they're actually for the same quadratic function. This is everything we did in section G3, or graphing quadratics. It's not necessarily an easy process, but it's at least the same process every time. Now, for our new section, there is one step that's different, which is solving. Okay? And we've been solving linear equations and functions for this entire year. So how do we solve quadratic functions? Well, before we talk about solving quadratic functions, I want to talk about solving systems of equations. Now, systems of equations were just lines that went through certain points. And the solving was finding out where the lines intersected. Okay, so the solution to a system of equations is where the lines intersected. Well, for quadratic functions, the solution is called a 0 because it's where it intersects the x-axis, where it intersects the x-axis, okay? And that would be where y equals 0, because y is equal to 0 at the x-axis. Now I have that same typo over here. Okay, so a solution is the same thing as a 0. If you're at your table, it's where your y value is 0. Or on your graph, it's where you intersect the x-axis. So for this equation, the points -2, 0, or the point 2, 0, those are our solutions. And if we plugged them into the equation here on the left, we would then create a true statement where y equals 0. And once again, it all ties back together. Solutions are where the where the quadratic is equal to 0. Now, there are 3 possible situations that we're going to deal with quadratic functions. Okay, the first one is called two solutions, and that's going to be where we intersect the x-axis 2 different places. So if I had one, and pardon my freehand here, it's not going to be very good. If I had a function that looked something like this, that would be 2 solutions here and here. Now, another example would be one solution. That would be something like where if it just hits this point, and then the function moves off like this. Okay, so that would be one solution. Now, the final example is actually 0 solutions. That would be something where you had a quadratic that looked like this, that never actually hit the x-axis at all. So that one would have 0 solutions. Now, these are the only 3 possibilities. It's either 2 solutions, 1 solution, or 0. So there is no magical 4th or 5th option here. So let's do one quick problem. Let's solve a quadratic function from the beginning. Okay, so we are looking for the zeros, or where the function is equal to 0. Okay, now the first thing we have to do is we have to figure out the a, the b, and the c for our quadratic function. In this one, the number in front of x squared is 1. The number in front of the x is -2. And the number in front, or left alone, sorry, is -8, or the c. From here, we need to do the opposite b over 2a to help us figure out the table's center, or the vertex. So opposite of -2 is +2. 2 times a is 2. So the center of our table is 1. So when we create our table, whoops, let's try that again. If we create our table, that means the middle value has to be 1. And then we can pick values that are equidistant away from the center. We can pick as many as we want. Now I picked a whole bunch, but we only need it until we hit a 0 over here. Now what I want you to do is I want you to fill out this table by plugging each value into the quadratic function. I'm going to do that and pause the video and see if our answers match. Now as you can see, one of the problems with quadratics is because the numbers get really big quite fast, you end up creating a situation where your quadratic doesn't fit on your graph quite frequently. So one of the things that you can do is using a tool like Desmos, you can graph your quadratics a little bit easier and then use this to help you create tables of values to help you make sure you're getting your points correctly. But you have to be able to do these by hand for any assessment. So make sure you're not just using Desmos to copy them down directly. Now, for our problem, the last step is let's solve the quadratic function. So this one has 2 solutions because it intersects the x-axis twice, or it has 2 zeros. Now, I spell zeros both ways, so I'm never actually sure which way they're spelled. So I would never take off a point for that one. But it is right here, and it's right here. So this should be at the point -2, 0, and the point 4, 0. So just to recap, when we're solving quadratic functions, there are 3 situations. You can either have 2 solutions, 1 solution, or 0 solutions. Those are also called zeros because they're where y equals 0 or where you're trying to intersect at the y or the x-axis. So for the review video, we're going to go through another example and show you how you can use this to solve some problems on Desmos Marble Slides. But as always, if you have any questions, please let me know.